We're going to look at inequalities in one triangle. So basically what we've done so far is compare two triangles to each other. We want to prove them congruent. Now we're just looking at inside of one triangle. Now this is a lot of inequality information. I'm just going to sum it up because you did this all in algebra. Basically, if you have two numbers, they're either equal to each other. One's less than the other. One's greater than the other. Right? Those are the only possibilities. Yeah. Transitive property. So this might be new, but you've already done transitive property with an equal sign. So now you can extend that to a less than or a greater than, right? If you have A is less than B and B is less than C, doesn't A have to be less than C? Yeah. Right, yeah, makes sense? Addition and subtraction properties. You guys did all this stuff in algebra. It's kind of like if I know x minus 3 is less than 5, can I just add 3 to both sides and I have x is less than 8? Those are all the applications that you did last year when you solved inequalities. This is nothing new. And then the last part is just multiplying and dividing. The only difference here is when you have c less than 0. Oops, I didn't mean to do that. If c is less than 0, what's that mean? That means it's a negative. And so if we have a negative, what happens to the less than sign? It changes to greater than. What happens to the greater than sign? It becomes a less than. That's all. Good? Nothing new. That's pretty much, the only thing that might be new is the transitive property, but even that you've seen with equals.
But why did you circle them?
Oh, I just wanted to show you that it flips. The sign changes. Right? Sign changes when you multiply or divide by a negative. Okay, because we're actually going to solve inequalities just like you did with Algebra 1 last year, but we're going to apply it to some geometric shapes, a triangle specifically. Does that make sense? Okay. All right, exterior angle inequality theorem. Now, we did an exterior angle theorem, which said the exterior angle was equal to the sum of what? The two remote interior angles. That's what those are called. So now that we have an inequality, and this basically says if you have an exterior angle, then its measure is, we have to figure that out, compared to the measure of either of the corresponding remote interior angles. Okay, we're working with inequalities. So in other words, we're saying the measure of angle 4 is what compared to the measure of angle 1. And then the measure of angle 4 is what compared to measure of angle 2. They're not equal to each other because we know measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2.
And it just always
has to be greater.
It's the measure of angle 2 greater.
Has to be greater.
Yeah.
Why does it have to be greater?
Because both of them make it equal. So
if you're missing one of them can't be 0 degrees. So no matter what, the exterior angle has to be greater than either one of those remote interior angles. Now, what about measure of angle 4 compared to measure of angle 3? They equal 180, but can you ever assume that angle 4 is bigger than angle 3? No. It looks like it is in this picture, but could I draw it so that the exterior angle was smaller? Yeah. So that's why it's only the two remote interior, comparing this angle here to these two, not to the one next to it. So in the next example, what we want to do is use that exterior angle inequality theorem. And by the way, we don't do any theorems with inequalities, just so that's why we're not going to have any proofs in this section in the next section. So all we want to do is apply these theorems. All I want you to do is list all the angles that satisfy the stated condition. So all the angles that measure less than measure of angle 8.
They're all less. 4 and 6.
Okay, now hold on a second. Here's what we have to do. Let's identify, so angle 8 is considered is that an interior or an exterior? Okay, so what we have to consider is what is in an exterior angle 2. Now we have multiple triangles that we're looking at here. So it's an exterior angle to
Triangle 4, 5, 6.
that one, 4, 5, and 6, but only 2 of them have to be smaller than it. Which 2?
4 and 6.
Good. Angle 4 and angle 6.
Isn't 5 smaller though, technically?
Yeah,
Nope, just because it looks like it, can't assume.
but we know
Do we know? We don't know for sure. It looks that way, but we cannot make that assumption. Now take a look at
The whole triangle.
the big triangle. Sorry. There.
So
But aren't you
2 and
asking
7.
specifically about?
No, but wouldn't it
Answer's
be
1.
2, 7,
Okay.
Answer 1.
Well, angle 1,
7 are the remote. 6.
so now we're looking at these would be your remote interior angle. So angle 2. And then 6 and 7 combined would be equivalent to this remote interior angle. So since I've already included 6, I'm going to include angle 7 as well. And that's all of them.
But it wouldn't be angle 6
would be
plus
like 5.
It wouldn't be 5. It can't be 5 because 5 is, it's an interior angle, but it's not a remote interior angle.
3 would
No,
be
I know
5
why
and
it's
6.
not.
3 would be 5 and 6. 3 is equivalent to 5 and 6.
It's
Listen.
just the other 2 numbers other than the one that would be in the linear pair.
Right. So let's say for example, I said angle 3. Okay. So I want to look at what is 3,
7 and 2.
6 and 5.
6 and 5. So I want to
Oh,
consider if this is
Oh,
the
I
exterior angle, it has to be bigger than 5 and angle 6.
Yeah.
Okay. What if I said angle 4?
Oh,
Then it would be 2 and 7.
So now it would be 2 and 7 because that's the exterior angle to these 2 remote interior angles. So, and then we could even do angle 1, right?
7 and 5 and 6.
So 3 and 7,
And 5 and 6.
and 5 and 6.
Why won't it be 4 though? Because 4 and 3 are.
Yeah.
Which one are we talking about now?
Because they're 4s.
For angle 1, why won't angle 4 be?
Okay, but 4 is not an remote interior angle to angle 1. Look at angle 4. If I look at the big triangle, it's going to be this one and this one, right? And if I look at the small triangle, it's going to be this one and this one. And no part of that did I have angle 4. All right?
Why is it 2 and 7? For the first one.
Which, I don't know which one. I was giving you so many different
2 and
examples.
7.
For angle 1?
Because technically,
No, for A, the actual question.
Oh, for measure of angle 8?
7 and 6.
So here's that picture. So 2 is a remote interior angle to angle 8, and 6 and 7 combined would be a remote interior angle. Well, I already had 6, so now I just have to include 7. Okay. I want you to try the last one. Just write them down. Let's not call out. Just give it this one's a little different. Now we want the measures that are greater than angle 2.
I don't think relevant, but how do we know when to put the M's and when not to
5.
put the M's?
No, 5 is the same.
We're just
No.
listing the angles, so you don't need an M.
4. No. wait.
Yeah.
Yeah.
Oh, I'm sorry. No, I'm sorry. See y'all.
I know. I said, let's think about it. Let's write them down so we can get them all. Everybody have a chance to write them all down? No. Okay. How many did we get?
2.
3.
Okay. So we want measures that are bigger than angle 2. So 2 is a remote interior angle. So we want to identify any exterior angles that would be associated with that. What do you have?
It's-
Yes.
I did for like all my three. I did 8, 1, and 4.
Okay, so do we know for sure angle 1?
Oh wait, no, never mind.
Can't
Wait.
assume.
They're,
Wait,
anytime
never
they're a
mind.
linear pair, you cannot assume. So if you look at a
No, 8 and
picture,
4, 8 and 4. never
8
mind.
is 1, because 8 is an exterior angle, and angle 4. Are those the only two exterior?
Yes.
Yeah, that's it. It's just 2.
Why 4?
So look at this triangle.
Oh, I see it.
You see it now? Sometimes it helps if you have like a colored pencil or highlight. It's just sometimes you're highlighting multiple things, so I know it can be kind of confusing. I know. It's easy for me. I can just do this and it erases. Okay, are we good on this one? Okay. Now we're looking at a different picture, but same idea. Now we just are given a series of angles. Determine which angle has the greatest measure. Okay, again, don't call out. See if you can identify in each set of angles.
We circle.
Yeah, just circle them, that's fine. Which angle has the greatest measure? This is actually, and I think you might find this a little easier.
Is it ever multiple?
There's only one in each set that is the largest. So you should only circle one of them. Do you have a question? Or are you done?
Oh, done.
Okay.
Oh,
Give everybody. Did everybody circle one?
Yeah.
Or write one? I don't care if you
I
circle.
don't know if I'm right.
Okay, really all we are doing is looking for which one is the exterior angle to the remote interior.
Oh, and then I got the first
The
one.
first one?
Okay, so for A, Sydney,
2.
2.
Oh, I got
3.
Zoe, for B,
I got
3. 3 is the exterior angle. Jessica, you have C? 3, same thing, right? Because it's just the exterior angle.
of all of them.
Are we good on these questions?
No.
I didn't do that on purpose. Okay. Okay, here we go. Theorem. So this one, I think the wording sometimes in these theorems is yeah, it's kind of hard to understand. It's almost easier to just look at the picture. But basically in this, I think this is one of the most obvious theorems. If you have one side of a triangle is longer than another side, then the angle opposite is going to be bigger than opposite the shorter side. Let me just explain. Let's say this is the largest side.
Wait, what?
Let's say that's the largest side. Then directly opposite, which would be angle C, will be the largest angle.
I didn't understand what that meant.
That's why I said the wording in the theorem sometimes is very confusing. So that's why I said let's just look at the picture. So, and if let's say, I don't know which one, let's say this one is the smallest side, then directly across from AC would be angle B. This would be the smallest angle.
But it doesn't work for isosceles triangle.
Right, so then those two would be, you could still pick like the biggest or the smallest. So for example, if I gave you, let's say I gave you, this is 100 degrees, and I said these two were congruent, right? Well, if that's 100 and it's isosceles, then these have to be 40 and 40. So this is the largest side, and then the two legs would be equivalent smallest sides, right? We don't know what their measures are, but we could still identify, you know, versus maybe a skinnier isosceles triangle, then the two legs would be longer and the opposite side would be the shorter one.
So if we're told to write the smallest,
Yeah, so I want to do that here.
we say both
Well,
sides?
yeah, you would say both. So sometimes what I'll do is I'll have you put them in order from biggest to smallest, and then you could just name them, and then I won't care which order you put the last two. So if AB is greater than AC, So now just kind of in notation, if AB is bigger than AC, then what angle?
C is greater than.
Then angle C greater than angle, I should put measure.
B or A.
I know, but I specifically gave A, so
Yeah.
AC.
So then it would be AC.
So it should be angle B, right?
Mm-hmm.
The way you could tell what letters to use, here's AB, what letter's missing? Here's AC, what letter's missing? B. That's just an easy way. So using the same concept on the next one, AB, so measure of angle C is bigger than measure of angle A. Okay. So we want to determine the relationship between the measures of the given angles. So I'm going to give you two angles to compare. And we want to see which one is going to be greater or less than. So we want to compare WXY. So that would be here. So that means we want to look at WY. I'm looking at WY, which is opposite. Does that make sense? Now I want to compare that angle to XYW, which is here. And so I look directly across, and that's XW. So in other words, to compare the angles, we have to identify the sides that are across from it. A quick, easy way to do that is just take the outer two letters. So kind of ignore the middle letter. So WY compared to XW. So which one's bigger? WY is bigger, right? We're comparing 14 and 12. Since this is bigger, that makes the angle across from it bigger. It's not hard. It's just sometimes, and especially when you have multiple triangles connected, it can get a little confusing. Okay, try the next two. Give yourself a minute to try. Let's not call out. So again, using the little trick that I showed you, you're looking at, so if we look at the first and last letter, you're comparing XY, it is on the, and then comparing that to XZ.
I like that trick of just taking out the
Yeah,
middle one.
it works the same. It works the same for the angles versus the sides. And then this one you'll compare WX to WY. Oh, thanks, XY.
How come when you're comparing the angles, though, you can just take it out and compare the lines?
Yeah.
I mean, the sides.
Because you're looking at the opposite side, not the angles.
Theorem of both.
The theorem?
You just take out the middle letter in the angle and then it becomes the side.
Yeah.
What if they
It's
don't
like-
give you the measurements?
Pretty much the angle, isn't it? Just like how long the side is across from it.
Yeah. Oh,
That's cool.
isn't that what I said? No? Did I say something different? Maybe because, like I said, the theorem sounds very wordy.
I already said it to myself.
Kind of like reinforce it. Okay, so everybody has a inequality. So for B, do we put in a greater than or less than sign? Less than. Do we agree? And for C, less than. Perfect. Yes, Sydney.
So you will always give us the measurements for questions like that, like the 12, 15.
I mean, no. I mean, I might give you some measurements, and then there's other information that you might have to take and apply that. This is basically the opposite, the converse, okay? This is the converse.
That is the angle.
Yeah.
Is the biggest and the size.
This is the converse of the previous one. So now they're saying, okay, angle C is larger than angle A. So what can we conclude? Well, what's opposite angle C? AB is bigger than opposite angle A is BC. I'm not putting the lines above because we're talking measurement, just so you know. And then here, the second one, what's that going to be? AB is also greater than AC. What's opposite angle B?
CB. Oh no.
This one.
AC.
So, now also angles, I won't always give you all the angle measures. I might only give you 2 within a triangle, and you have to find the third. But you can find the third, because 3 angles have to add up to 180. Or I might give you an isosceles triangle, and you have to identify the 2 that are congruent. This one's very straightforward, because all the angles are given to us. But let's compare LM to LP. So LM, so now if we're looking at LM, I'm really looking at angle, right, 59 degrees there. And then LP is opposite 83. So which one has to be? LP is bigger? All right, take another minute. Let's see if you can come up with.
And then MP will be the biggest.
Yes, you have a question?
Did you say MP?
Okay. The next one, MP, could be opposite 2 different angles. So when I'm looking at MP, I actually can't circle which angle I'm looking at until I look at the other segment. Because it's MN, I know I'm working with the triangle on the right. So that means I'm not circling 38, I'm actually circling the 79 to compare. Does that make sense? So when you have multiple triangles connected, you could have one side that's opposite 2 different angles. So this one with MP, I kind of wait to see which one I'm looking at to see which one I'm comparing to.
Compare angles from different triangles.
Okay, so that's an excellent question. I actually, when we're done with this, I'm going to give you a sample bonus question. Well, I'll say it's bonus for now. You might eventually have one. So go ahead and do that. And then I want you to think about this one.
LP. Oh, I know the answer.
Okay, so before we do that, I want to make sure we're all good on the other inequalities.
Can we continue with those answers?
Did we have enough time yet? Yeah, don't do the bonus yet. Do the other ones. Did everyone write down the inequalities? Okay, so for B, do we get less than or greater than? Greater? Yep. Yeah? MP is greater because we're actually comparing the 79 to the 44 that time. MN compared to NP. MN, which one is it? Less. And MP compared to LP? Less. All right, now we were able to figure those out based on just looking at one triangle at a time. But we have this whole figure. There is a largest segment in the whole figure. And what is it and why? What do you think, Ness?
I don't know if this is wrong.
It's okay.
I think it's NP because it's like kind of is like 2 sides.
MP?
Yeah.
So the problem we have here is we have 2 battling angles. We have a 79 degree and we have a 38 degree, which means, this is kind of strange, but this is the smallest side in this triangle, but it's the biggest side in this triangle.
So it's in the middle.
Any other ideas, Sydney?
LN.
LN.
That'd be the altitude.
But it's not a side shown. It's not, we don't.
So we can't assume that. I mean,
It's not a side shown in that I should have said which segment that's drawn, but
okay.
yeah.
Would that be considered?
Because it's not a side anyway.
Yeah.
But interesting. Jessica?
LP.
LP. It is LP. Why?
Because it has the greatest angle measure opposite of it.
Yeah.
Also, we do the thing.
What's the
Okay, that's one way to look at it. The other way too, if you look at this, look at the triangle on the right, for 79 degrees, NP would be the biggest side here, right? Let's just give it a number. Let's say it's a measure of 8. Makes sense? We'll just say this is, let's say this is 6 and this is 5. I'm just giving random ones. We know this would have to be or no, I switched those around. Thanks, I have those switched. Sorry. There. So this one is in the middle, and then this one's the smallest. Now, ignore those two and just look at, if this is 8, this is now opposite 38 degrees. So wouldn't LM have to be bigger than that? Maybe it's 10. And then here, if this is 10 and this is opposite 59, then opposite 83 has to be even bigger, right? So maybe that's 13. So it's almost like you have the two triangles are battling out the biggest versus the smallest, and you kind of have to figure out of the whole thing what's going to be the biggest side.
So you kind of just look at the biggest angle and look at it's probably going to be the side opposite to it.
Well, that's a good question. What do you think? Is that always the case? Let's think about that.
Yes.
You think so?
Because, well, the way you're looking at me means it's no.
I don't know.
I don't think it is anymore.
Let's think about that. Could we draw a counterexample of that, or would that always be true?
Well, you already said it's yes, it's true. I'm sure we can.
All right, let's take a look at example 5. Find the value of n. We're going to list all the sides in order from shortest to longest. And this, I would recommend just drawing a quick picture. It does not have to be drawn to scale by any means. I'm just going to put in P, Q, and R. So this is, so what do we know about all 3 angles? They have to add up to what? 180.
Are you still answering my question from before, or did we like take a break from that?
We took a break from that.
Oh.
Can you address more types of problems with, like,
Sorry, I wanted to finish the lesson, and then we could.
on our homework, is there any more problems with us trying to figure out the large side? Like
I'm trying to remember. I know I definitely have some questions like that on a quiz or a test. We'll have to see. What do we get when we combine everything here? 25n, and then plus 55. So 25n equals 1.
Oh, it's 125.
And then n equals 5. Okay, so now we want to plug it back in. So angle P, so 12 times 5 is 60, minus 9 is 51, right? Angle Q is 62 minus 3n, so 62 minus 15.
47.
And 16 times 5, 80, plus 2. I would always recommend just adding those all up, making sure, do those all add up to 180?
Probably.
Yeah.
It seems like
It seems that way. Okay. And we want to name them the sides, not the angles. Shortest to longest. So what's the shortest side? PR. And now we're listing them, so I'm putting the segment sign above. And then QR. And last,